Course 3, Lesson 49, we are looking at some rate problems and proportions and being able to solve those. So, we first need to know what is a rate. First, all of these ideas kind of come together. A ratio, we have a comparison of two quantities. And there's lots of different ways to write this, remember. We can use a fraction, we can use this colon or the word to separate it, but the order matters. If we say the ratio of girls to boys, then we know 12 is the number of girls, 13 is the number of boys. A unit rate is a rate for 1 unit of a given quantity. So, if in this example we drive 130 miles in 2 hours, our unit rate, we want to know how far we drive in 1 hour. So our unit rate is 35 miles per hour. And a proportion we know is when we have two equal ratios. So we could say something like 2/5 equals 4/10. That is true because 2/5 it has an equivalent fraction of 4/10. But if we did like 3/4 and 6/9, that would not be okay because those are not equal ratios. But we can use equal ratios to solve these rate problems. Let's start out making sure we know what these are. A blank is a ratio that compares two units. That's a rate we're talking about. And a blank is a blank per one given unit. Well, a unit rate is a rate per one given unit. Rate is the overall term. Unit rate is a specific type of rate where we have one given unit, typically shown on the denominator of our fraction. And a little hint, it's typically, if time is involved, time is typically our 1 unit that we look for. Okay, so if we are looking at this problem, let's say the temperature rose 18 degrees in 6 minutes, something crazy like that. Well, I want to know my unit rate. And yes, we could figure out how many minutes it takes for 1 degree, but in this case, since minutes are on our denominator, we want to find how many degrees per 1 minute. And there's a couple ways to think about this. We know we need to divide to be able to simplify this, and so we say 18 divided by 6 is 3. So that's one way, is just divide the two numbers, and we end up with 3 degrees in 1 minute. But the other way to think about this is if this is a fraction and I want to simplify it, well, I need to do something to the top and something to the bottom. So I could divide each of those by 6 and get 3 over 1. Let's try another one. 25 kilometers in 27 minutes. So in this case, it looks like I am finding how many kilometers in 1 minute. Well, to get there, I'm going to divide by 27. So if I do that and divide by 15 divided by 27, we end up getting 0.5 repeating kilometers in 1 minute. So just divide them. And we end up with our unit rate. We're looking for that 1 minute, the 1 hour, the 1 apple, whatever it might be. Let's look at this example. The Space Shuttle Endeavour climbed 71 miles in about 8.5 minutes. What is the shuttle's rate of ascent? Well, in this case, it's telling me I want to know the rate of ascent, which means I want to know how many miles I go in 1 minute. So I'm going to divide 71 divided by 8.5, and we do end up getting, and I'll uncover this here, we do end up seeing that we get 8.4 miles per minute. Here are a couple other examples that you can try. This one I'm actually going to switch around. Typically we don't find how many, for $1 how many tickets we do, so we would see $20.25 for 3 tickets, so we would divide. 42 muffins in 8 minutes. Think about how many you can eat in 1 minute. And now let's look and use the unit rate to solve this problem. If 6 books weigh 15 pounds, how much would 20 books weigh? Well, let's figure out how many books or how many pounds it is for 1 book. So right now we have 15 pounds is 6 books. So if I am going to 1 book, I'm going to need to divide by 6. So if I do 15 divided by 6, I end up seeing that that's just 2.5. 2.5 pounds for 1 book. Now if I had 20 of those books, I would say, well, if that's 20 books, I need to multiply by 20 books, which means that I see that it's going to weigh 50 pounds. 50 pounds for 20 books. So we can use the unit rate to then expand what we know about a certain thing, because we are working with proportions. So we can scale it up or scale it down. All right. Let's try one more like this, and then we'll do some simple ones. Jenny is riding a 50-kilometer bike race. If you pass the 15-kilometer mark in 27 minutes, if she rides at the same rate, what will be her time for the whole race? So there's a couple ways to go about this. In this case, we're going from 15 kilometers to 50 kilometers, so maybe it will be helpful to figure out how many minutes does it take for 1 kilometer. Well, right now we know 27 minutes for 15 kilometers. So maybe we figure out for 1 kilometer and then scale it up for 50 kilometers. So I do 27 divided by 15, and we end up seeing that it takes 1.8 minutes for every kilometer. Since this is a 50-kilometer race, I'm going to multiply by 50, and 50 times 1.8 gives us that she will be on this race for 90 minutes. 90 minutes. Okay? That's one way to do it. Okay? The other way, we could figure out the other way around, just like we did in the earlier problem. And we could say, all right, if we want kilometers per minute, that means we're going to do 15 kilometers for 1 minute, for my 27 minutes. And we figured out that that was 0.5 repeating kilometers for 1 minute. Okay. And so we could then figure out if this is my rate. So my general equation is distance equals rate times time. And so I could plug in, I don't know that my distance is 50. I know that my rate is 0.5 repeating, but I don't know my time. So I could take that 50 and divide it by 0.5 repeating and see that we do, once again, get 90 minutes for my time. So a couple ways to do this problem. All right, here are some simple problems that we can look at. We'll just do a couple. If Rashida bought 3 tickets to the concert for $75, how much will it cost for 5 tickets? Well, in this case, a good way to go is figuring out that unit rate. And we see that 1 ticket is $25. So we end up seeing 1 ticket is $25, so scale it up, 5 tickets is $125. Okay. Nicholas bought 5 pens for $3. How much would he spend on 10 pens? Well, this is just a equivalent fractions one. If 5 pens is $3, we can multiply by 2 for each of those and see that 10 pens is $6. Okay, and just use a proportion. For this red one, if Rashida spent $100 on tickets, how many did she buy? Well, if 3 was $75, we know that 1 ticket was $25, so 4 tickets must be $100. Okay? All right. Couple more, and then we will finish. Find the value of the 12th term. Well, it looks like if we have our first term, it's 2. Second term, 4. Third term, 6. Looks like we're multiplying by 2 here, which means that if we want my 12th term, the value would be 24. Let's see. There we are. 12 is 24. All right, a couple more. The table shows the number of miles Chantel runs each week while training for a marathon. If the pattern continues, how many miles will she run in week 5? So 1 to 6, 2 to, or 1 to 3, 2 to 6, 3 to 9, 4 to 12. Looks like we're multiplying by 3. So would she run 15 in week 5? Looks like it. Okay. So distance, we could plug in that it's times 3 here, or we add 3 for every week. Okay. I think that was this one and our red one. 3 hours worked for $18, so 5 hours worked for, well, this is just a proportion that we could set up. 3 over 18 equals 5 over $30. Okay, each hour is $6. This is a good unit rate one as well. And lastly, the school cook uses 10 pounds of potatoes to make mashed potatoes for 40 students. How many pounds does the school cook need to make mashed potatoes for 120? Once again, you can do a unit rate or a proportion, but regardless, we're going to see if we have 120 students, that's from 40 to 120, that's times 3. So our pounds, we are going to have to multiply by 3 and get 30 pounds of potatoes. All right. So with our unit rates, remember, lots of ways to solve them. Use your proportions, use your equations, use your scale factors. Regardless, I hope this is helpful for your homework and for studying.